So we're going to have a look at question 8, and question 8 is on a toy car of mass 0.2 kilogram that's traveling in a straight line. Now we're given the net force, so that is the sum of f of x. We're already given the net force, so any forward force minus any backward force, we're given it together as one force. So let's assume the car is moving to the left. So we'd have a left force like this, and the magnitude of that force is 1 over 10x, or x over 10, same thing, multiplied by 4 minus 3x. So immediately you can see that the force in this question is with respect to distance x. Now we have a weight acting, which is 0.2 kilograms. So 0.2 multiplied by gravity, mg, and we have a reaction force acting from the ground onto the toy car. Now this toy car is traveling to the left hand side, so I'm going to put a symbol here saying left side. Now let's develop a mathematical model just as we do with all these questions. Sum of forces in the x direction is equal to mass times acceleration in the x direction. It's going left, so left will be chosen as positive. Now let's write our net force down. So f of x we have in the question, x divided by 10 multiplied by 4 minus 3x equals ma. Let's expand the bracket on the left. So we get 4 over 10x minus 3 over 10x squared is equal to the mass, which is 0.2 multiplied by a. Now, since we have x in our equation, and the question is asking for, part A asks for, an expression for velocity as a function of x. It means we need v and x in our equation. Now normally we replace a, let's put it down here, we make a is equal to dv over dt. Another way of writing a is v dv over dx. And the reason for that is because a can also be written as dx over dt multiplied by dv over dx. It's the same thing. The x's can cancel and you go back to dv over dt. Now instead of cancelling the x's, all we simply do is say that dx over dt is a change in x with respect to time, which is the same as v, and dv over dx stays the same. So this here is another way of writing acceleration. We use this when we have x and v. See, we have x here in our question. X, and we have velocity as well. We have velocity. Now, going back to our equation, we've replaced a v dv over dx. Now, let's look at the equation. We need to separate the variables, have v on one side and x on the other. So I'm going to multiply both sides by dx. So we have 4 over 10 x minus 3 over 10 x squared, all multiplied by dx is equal to 0.2 v dv. Now the variables are separated, but I always like to put the numbers on one side and the v on the other side. So I'm going to take this 0.2 and divide both sides by 0.2, taking it over here. So it becomes 0.2 times 10 is 2, so that becomes 4 over 2x minus 3 over 2, because 10 times 0.2 is 2, x squared dx equals v dv. Finally, let's simplify that fraction a little bit, so it becomes 2x minus 3 over 2 x squared dx, that's all multiplied by dx, equals v dv. And now we can integrate both sides with respect to their variable. So, let's integrate. The integration of 2x becomes 2x to the power 2 all over 2 minus 3 over 2 stays the same, x to the power 3 over 3. Remember, the integration, you add 1 to the power and divide by the same number. Now, the integration of v will be v2 over 2 plus a. And this is the general solution of the equation. Now we have to find the particular solution, which means substituting v and x and finding a. So we need some boundary conditions or initial conditions. Well, we're told that the car comes to an instantaneous rest when x is equal to 6. It says that in the question. So rest means velocity is 0. So when x equals 6, v equals 0. So let's substitute those values into our equation. So our 2 and 2 cancel from here, so that makes x squared. The 3 and the 2 combine to make 6. So our equation is going to be x squared. X is 6, so 6 squared minus 3 over 6, which becomes half. X to the power 3, 6 to the power 3. And then equals to 0, because velocity is 0, plus a. So now we can rearrange this equation. So it becomes a is equal to, so a is equal to minus 72. Plugging this back into our equation, we then get x squared minus x to the power 3 over 2 equals v squared over 2 minus 72. Now we want v as a function of x, so v equals something, x. So we need v as the subject. Let's start by adding 72 to both sides. So it becomes x to the power 2 minus x to the power 3 over 2 plus 72 equals v squared over 2. Now, let's multiply everything by 2 to get rid of the fraction. So it becomes v squared, starting with the other side, equals 2x squared minus x to the power 3 plus 144. Finally, square root both sides, so we have v by itself. V is equal to the square root of 2x squared minus x to the power 3 plus 144, which is the same thing as the answer. The answer is put to the power 0.5, which is the same as square root. The final part of the question, part B, says find the initial speed of the toy car. Initial means at the beginning, so when x was 0, when it hasn't moved any distance yet. So all we do is substitute x equals 0 into the above equation and find what the speed was. That will be the initial speed. So v equals the square root of, since x is 0, this becomes 0, this becomes 0, and we're left with 144. Square root of 144 is 12 meters per second. So that's the initial speed of the toy car when x was equal to 0.